Yep. So going through logarithms. So logarithms, we usually express this as log. So when we're talking about logarithms, usually the term we're going to see is just like what we have up here. We're just going to see it as log. So this is going to be the general form. This term down here, that's how we express logs. Basically, when we say we're taking a log of something, we are taking a log. If we say we're taking a log of 10, or in this case, we're taking a log of 100, right? In this first example. If we say log of 100, all we're doing is we're taking 100 here, right? And in further math, so in general mathematics, we're only really going to be looking at base 10. When we say base 10, I'm referring to this little section down here. So this number down here is our base, right? So if you ever see that, we're talking about log base 10. We're talking, the base is the little number down here. And when the number that we're taking it of is the number in the brackets. Another quick thing that I want to go over is just, and I don't really feel like the textbook explains this very well, so if you get everyone's eyes up here, even if you're working on your notes, I just want everyone to understand this. When we're going through this stuff, if it is log 10 to the 10, and so if we're taking log 10 to the power of 5, what we can do is we can actually move that 5 up the front of the log. And it's something we call a log law, but we won't really touch on that too much in general. But we bring that 5 out the front of it, out the front of the number, and we multiply the whole thing by 5. And also the log, if it's a log base 10, if it's any time the number, if we're taking the log of a number and it's the same as the base, it's always equal to 1. So we won't really touch on this, but if we had log base 7 and we took the log of 7, that's also going to be equal to 1. So that's a nice little thing that the textbook doesn't really cover too well. It kind of touches on, but it uses examples to show you, but doesn't explicitly say it. So I just want everyone to make sure that they understand that distinction. And then we'll go through this. So using what I've just looked at, we can actually convert this number, this log, to the 100. If when we're doing this question, we can say that this is equal to log of base 10 of 10 squared, right? Because you can convert that 100. And then because we can bring that power of 2, we can bring that up the front and we can multiply it. So we can say it's 2 times log base 10 of 10. And as we know, log base 10 of 10, because it's the same, we're taking the log of the same number as the base, we can say that that's equal to 1. So we can say that's equal to 2 times 1, or we can just say that that's equal to 2. So that's generally quite a nice way of doing it, but we can also, just as another example, we can also do that for numbers like decimals. So if we have 0.001 and we want to have log, and we need to write that as a power of 10, so we can write, if we want to write 0.001 as a power of 10, we're going to get that is equal to 10 to the negative 3, right? So that's saying it's going down in decimal places. And then we can use that if we take the log, if we wanted to find the log of 0.001, we take the log base 10 of 0.001. That is the same as saying we're taking the log of 10 to 10 to the negative 3. And then again, we can take that negative 3, that power of negative 3, and we can take that out the front of the log and multiply it by its to get log base 10 of 10, which will just be equal to negative 3. Does anyone have any questions about logs? Okay. In that case, we are also going to go through 1M before, just in the notes, and then I'm going to let you start on the exercises. So also if you need, I know it's in your textbook as well, but if you do need and you can't think of it on the spot, we also have a conversion table for the powers of 10. I know that's in your textbook though, but feel free to copy that down. I'll pop it up at the end after we go over 1M though. So, 1M. So we're looking at order of magnitude. So when we're talking about order of magnitudes, if we're talking about increasing an object by a magnitude of 1, we're talking about increasing it by a multiple of 10. So we're multiplying whatever we have if we're increasing it by an order of magnitude of 1. So specifically order of magnitude of 1, we're just multiplying that number by 10 if we're increasing it. Now, it says in your textbook, and you might see it, we say that we increase by n orders, right? And we're using n to represent whole numbers here. So we're saying n can be equal to 1, 2, 3, 4, but we usually don't say that it's equal to a decimal. However, you might see that in your textbook when we're talking about things like earthquakes, because we can have magnitudes, earthquakes of magnitude 8.5 and stuff. You might see that. So we're just talking about n as a power of 10. So if we say n orders, if I'm talking about an increase of order 2, we're talking about an increase of 10 to the 2. So increase of order 2, we're talking about increase of 10 to the power of 2, which is equal to 100. So for every increase in magnitude, we're just going to multiply the number by 10 again. So if we're increasing by an order of 3, then we're going to be multiplying it by 1,000. So just going up by 10 for every order, right? So that little number up here is what represents the order that we're increasing it by. We can also have, we also have decreases, and that's a similar thing. We can either divide it by 10 to the power of n, right? And where n is our order of magnitude, or we can also multiply it by 10 to the negative n, because that's going to be the same thing. So that's for decrease and increase. And if we're looking at, say, a question like this, where it says, what is the order of magnitude of 1,200? We're not going to, we don't know what it's increasing by, right? We need to figure out what its base state is. So we call this standard form. And what we're going to do is we're just going to look at this standard form. So when we convert it to standard form, we just want it as one digit. So if we say 1,200, 1,200 in standard form is going to be equal to 1.2, right? So we just want that first digit. We want to get it down to this, and then we want to multiply it by 10 to the power of 3. So we just want to get that first digit by itself, so we divide it by whatever it is, and we figure out how to express it in terms of 10. And whatever power that is, so this number up here, that's going to be what our order is for this number. So in this case, we would say that this number, 1,200, has an order of magnitude of 3. Because n up here, or if we say that's n is going to be equal to 3. Does anyone have any questions about that? Just remembering that this form up here is called standard form. And we need that to calculate the order of magnitude of a number by itself when we're not looking at the increase or decrease. Okay. I'm happy for you to start on the questions now. I'm going to come around with a